what I appreciate about Harmony's approach is that you've developed a sophisticated approach to personalized learning in a blended setting. So students have a lot of individual skill building that happens in reading, writing, and mathematics, and that prepares them for project-based learning, taking on really interesting and challenging real-world projects, sometimes as a team, sometimes as an individual, but doing really interesting work, creating high-quality products, usually presenting that to a public audience, often building an infographic about it, making a PowerPoint about it, giving a speech about a topic. And so the combination of personalized learning that creates an on-ramp for a student that might not have very good preparation when they come to your school, and that gets them ready to do really interesting and challenging and motivating work. I think that's the best model of school that we've come up with.
I honestly believe that working in this setting where students get to work with hands-on projects and build, a full-scale car, I think this is the best learning environment for any science or math-related course, simply because you see the full application of what you're learning in the classroom, and you're able to not only visualize the concepts, but you're able to test them. There's trial and error here. You could work a problem out on a piece of paper, but you never know the actual effects of what you're planning. So here the students are able to make their own choices and see the consequences of those choices. So not only is this valuable for the classroom, but it's also valuable for life. Because here, say a student orders materials and they realize that the materials were wrong. In future occasions, they'll make sure that they order the right materials. And here it might be a minor issue, say $10 or $20 difference, but in the real world it could be hundreds of thousands of dollars and maybe cost them their job. So they're not only learning valuable skills that they can apply in their careers, but they're also learning skills that they need just for life. And this is something that not only you can't get in the classroom, but it's not really something you can get in any of the other activities that we have, simply because this is such an advanced project.
The difference between being taught something and learning it yourself is very different. For example, if you're being taught an equation and you don't really get it, you're not gonna master that equation. So if you were to do it by yourself multiple times and figure out your mistake and then solve the problem over and over again, you're gonna get it. So SOS, Students on Stage, is actually an amazing way to teach something, because I'd never thought that I'd build a car, because I drive a car every day, but I don't know what goes behind it. So being able to participate in this specific club, it's taught me the mechanics behind how a car is built, how the mold is built, how everything that goes into a car is built.
In the beginning, what kept me motivated was the idea of building a car. I honestly did not think it was possible, what, we're gonna build a car? It didn't seem real to me. And the fact that I wanted to see whether we could do it, that gave me motivation in the beginning. But later on, as I realized that, well, we really were building a vehicle, that my motivation came from coming every day to school and knowing that what we were doing was not time that was being wasted, but time that was being spent on something that would enrich our lives. You know, every day we would come in and we realized that what we were doing, you know, not a lot of high school students do this. Not only that, but all the stuff that I learned here has helped me in my life in some other way, you know, whether it's learning about specific stuff like the fiberglass and how to make the mold of the car to the engine, or whether it's just skills like talking to people and knowing how to communicate your ideas and share dialogue with others in a respectful way. All that kind of stuff motivated me and inspired me because I realized that I was doing something that was really going to be good for me in my school.
Well, yeah, I got a lot of problems before we start the project and during the project. And I just want to start a little bit before the project, what problems we faced. Well, actually it's not an easy project. It's required a lot of money. So you need to invest some money in it to make this project at least start. And this is the first thing I discussed it with my administration, and they were supportive on that. And they told me like how much money we can get out of this one. For the project. Another problem was to find a design or to get the students who know how to AutoCAD and design something online. This is, I guess, the hardest part I faced, and we're trying to learn these skills with the students, but unfortunately we couldn't succeed it very well, but still we get our design. Those are the designs actually before we start to build our project. And after that, we start our project, but still we need material. Still we need students to get more dedicated, and still I need to motivate my students to work on this project. And this is the most complicated part or problems in the project. But thankfully we finish it, and I'm proud of my students at the end. Basically, I just want to go like about problems I face here. And when we are building the project, it's hard to stay very late after school because I'm working like since 7:30 here in the school, all day up, and to keep up here with the students is really difficult. This is the hardest part for me actually. And on the other hand, to purchase a material, to get found for this, get the payments done and follow all those jobs is really a problem for me.
What did I learn? So first, I really learned how to like maintain like communication with other teams, because throughout the whole time we were building a car, there were certain teams I had to keep contact with and like ask them for like tips and like ask them how they made their car, and like ask them like where they buy their fiberglass and whatnot, and also like building the mold and like just like using fiberglass in general and all the different like process that goes into it. That was really new to me. And then also building the fuel injection system for the car with NASF was also really like interesting and challenging because it like took a long time to actually get it to work. So that was pretty nice, and I don't know, it was a nice learning experience. Like I never knew like how like fuel injection worked. I didn't know how like fiberglass worked, and it was nice. And like the whole time being here and like actually like working with other people the whole time is really nice. You know, one day you might be working with like NASF to build fuel injection, you might be working with Oli to like paint the car the next day. It's really nice.
So our young people are graduating into a project-based world. We think 4 out of 10 will become freelancers working on their own. Another 40% will join organizations, but inside those organizations they'll manage their work as a sequence of projects. And so whether it's freelancing or joining an organization or going back and forth between those two, young people are going to step into a very fast-paced environment where their career is really a sequence of projects, where they have to do real-time learning to meet near-term objectives, where they're going to have to stay curious and connected to be really successful. And I think the best way to get kids ready for that environment is to simulate that environment in a project-based learning environment where they're both doing real-time skill building that gets them ready for integrated projects.
Well, like I said, I was a captain, but I was also the electrical person, so I did most of the electrical on the car. And so the horn, the lights, the AC unit, basically fans that blow at the driver while he's driving because it gets really hot in the car. And as a captain, I also kind of led the team towards a direction of what they should be doing each day, as well as with Johnny, our mentor.
Not too much pressure, just a little bit of pressure.
It was pretty confusing at first because we didn't have any background knowledge. None of us did. But we looked at other teams' designs, got a bit of ideas, got some ideas, and we started sketching the design on paper. Little bit by little bit, we improved and got better. And our mentor Johnny really helped a lot. So thanks to him, we actually have a car now.
The purpose is to build a full efficiency car and take it out and compete. And when I say this is not a high school friendly competition because most of the teams is from college. And the component is like what we are competing against is the college teams. And here with the high school students, we complete this project, we finished our car, and we went out and compete out there. And yeah, as I said, it's a full efficiency project. You have to design a car and should run with less power or less gas.
So the Shelly Marathon was started with the intention of making, I guess, very fuel-efficient vehicles. So I guess you can go back to the global warming thesis that was introduced post-50s by scientists. And the idea is basically that you have, I guess, the greenhouse effect, which means a lot of gases such as CO2 are trapped in the atmosphere, and they prevent the sun's radiation from escaping. So basically it leads to a warming of the earth and melting of the polar ice caps, and you can continue with that explanation. So the human race has decided that they don't want to continue heading in that direction, so we made a shift to making our vehicles, our homes, etc. more fuel efficient or more energy efficient. And this race is basically encouraging young high school students and college students to pursue a career, I guess, the innovation of technology with that intention. So that being said, normal gas-powered vehicles usually have a fuel efficiency of anywhere from 15 to around 15 miles per gallon. 15 for the larger SUVs and trucks, 50 for the more efficient hybrids and smaller cars. But this competition goes way above that. As I said before, the University of Laval, a Canadian team who won the Shelly Marathon this previous year, went well above 1,500 miles per gallon. So if you compare that to a normal car, that's 15 times that, or it's amazing what you can do with these revolutionary materials, and new research is coming out.